So, you can see everything? Okay, perfect. Welcome to Java Reg with SpringAI, Elasticsearch, and board games. We'll get to that. First, very quick introduction. My name is Laura. I'm from Italy. I am a backend software engineer, work mostly with Java. Currently, I'm employed by Elastic. I maintain the official Java client for Elasticsearch. It's public on GitHub, so you can find me there answering issues every day. Disclaimer, I am not an AI expert, so I use AI as product, but I don't know what goes on underneath. I mean, I kind of know average knowledge. So yeah, just so you know. So what we are going to do today, we are going to see what RAG is and explain how useful it can be. We are going to explore the tools that we can use to build a RAG application with Java, of course. And finally, we are going to build and hopefully run the application, see how it works. I did mention board games, so are you familiar with board games? Did you play them? Kinda, yeah. So you probably have played at least one game of Monopoly or a version of the game of the goose. Do you have the game of the goose in Poland? You don't? It's I thought every country had a version of the game of the goose. So, but these are the simple games that have like 5 pages manual. We can set it up quickly and play a game with friends. And we are not interested in this kind of games today. We are interested in the more complex ones, like Warhammer or Dungeons and Dragons. These games, you have no hope of setting up a quick game without having years of knowledge, because the manuals are actually thick books that can fill entire shelves of your library. And so I was thinking while setting up, I play Dungeons and Dragons 5th edition, and I was thinking what AI is very good at, language models. They are very good at going through lots of information and extrapolating important parts out of it, the ones that you want. So for example, if I want to search for a specific rule or an interaction between rules, instead of going to my library and spending the next half hour looking for a rule, I could just ask for the answer from a chatbot. Tried that, didn't work very well, because for example, in the case of Dungeons and Dragons, the answer to the rule can depend a lot on the edition, the revision, which manual are you using? Are you looking for something that in preview? And then the chatbot can confuse, what's official information, what is made up by users. So what we would like to do is just take the manual that we have, the physical one, and getting information from that. And I would like to continue with my Dungeons and Dragons example here, but the publisher wouldn't be very happy with what I'm about to propose that we do with their manual. So I'm going to switch to another game. Has anyone ever heard of Rune Wars? And you would surprise, you did. But I'm surprised. It's a fairly niche game, and this is the edizione italiana. It says is the one I have at home. So, kind of Warhammer-like. Let's say there are miniatures, and you go, you can conquer lands and defeat enemies, going through terrains. So, the manual, which I actually have, I forgot. Here it is. The manual is quite a bit shorter than your role-playing game average manual, but still the concept applies. I would like to have information from here to give to a chatbot to answer me. And I'll leave it here. Try doing that with ChatGPT, and it is absolutely clear that it doesn't know shit about Rune Wars. So tried asking something very simple. There's reward cards, and where do you put a reward card after obtaining it? Where in the game, it must be put face down underneath your hero card because it's secret. And ChatGPT says that it has to be easily visible. It's not. This one is even better. So in the game, as I said, you move miniatures units through the terrain, and there are water terrains that only flying units can go through or using special cards, or in winter, the water freezes in the winter season of the Rune Wars game, and so every unit can go through it. ChatGPT makes up a completely non-existent type of unit that doesn't exist in any version or expansion of the game that I checked, and completely ignores every other rule. So given that we have proven that ChatGPT doesn't know anything about Rune Wars, how do we take that exact manual and extract information from it? This is exactly what RAG is. So RAG stands for Retrieval-Augmented Generation, and it basically means taking your personal private data and adding them to the knowledge base of an LLM. And it can, I mean, I used a game manual, but it can be anything that you want, really. So it can be like your company privacy policy that nobody's going to read. Or, I don't know, you're about to sign a user agreement and you want to be super sure that you are not selling your soul to whatever service you're about to use. So this, what it does, it also decreases significantly the probability of hallucination, because we're going to ask to the LLM explicitly just to use the information provided in the relevant data. And if it doesn't find the information there, it must not make up anything. A bit more on how RAG works. So we have our additional documents, and step one, we need to encode them first using an embedding model. And encoding means extracting the vector representation of the data, so that we can store, step two, both the vector representation, which is basically an array of numbers, and the text representation into a vector database, which is a database specialized in handling this kind of vector data. So, step three, when we ask for our question, the question has to be encoded first, using the same embedding model, of course, so that then the vector database can perform, step four, a similarity search, which means comparing the vector representation of the question to the vector representation of the documents. And so step five, it can return to you the documents or the part of the documents that it deems that are more similar to the question that you just asked. Step six, sorry, we can then take the text representation of our, the relevant document and the query and create a prompt that will give to the language model, which step seven will hopefully return something relevant. I mean, most probably it will. What are we going to use as tools to achieve this architecture? So we are going to use SpringAI to build the whole application. And anyone familiar with Spring? Or sure. Okay. So SpringAI, latest library from Spring, basically does what normal Spring does. So adds another layer of abstraction to the Java code, making it super easy to connect with AI-related tools. As a vector database, I'm going to use Elasticsearch. I'm going to start a local instance, and I'm using that, of course, because I work there and I know how it works, but also because if you look at the SpringAI integration with Elasticsearch, it's written using the Java client, which is the library I maintain. Also, I helped writing said integration. So these are all good reasons for me to use Elasticsearch. But if you know any other vector database which is supported with SpringAI, you can use that, and I'm going to show you during the demo how to switch it. It's super easy. as both embedding model and chat model, I'm going to use OpenAI, and this is just because it's easier to demo. But again, if you know better any other language model, you can just check in the SpringAI documentation what it supports and just use that. So let's see in the diagram before how our tools integrate with RAG. So the additional documents will be, of course, the Runewars manual. Vector database is Elasticsearch. Embedding model OpenAI, LLM ChatGPT, and everything is orchestrated and written in SpringAI. Now, it's time for the demo. You can use the QR code and it will bring you to the GitHub repo where the demo is already all set up. I'll give you some time to scan this. I'm right on time. And I will now proceed with coding the application. Okay. So we are going to, no, I'm going to use, another use for the Runewars manual is as a mouse pad. Perfect. We are going to open our favorite IDE. And so I have like a blueprint of the application already set up. Otherwise, it would have taken too much time. But we'll see every class and every setting. And let me quickly start the local instance of Elasticsearch. Otherwise, it might take a couple of minutes. This is start local, by the way. It makes it basically instant to run Elasticsearch and Kibana. And while it is, okay. Here we go. So, Maven, of course, this is Maven as dependency management. Let's start from the parent Spring Boot application. So, of course, we need the Spring Boot parent. This is the description. All of the dependencies that I'm about to pull are still in preview. So, we need to add the Spring Milestone repository to the list of repository. Using Java 17. The SpringAI BOM has to be added to dependency management because otherwise it won't find the dependencies. And now let's start with the actual dependencies. So SpringAI boot auto configure we will use to have a default implementation of every service that we're going to use. So we're not going to set up manually any beans. We're just going to use the auto-configured ones and setting the parameters with the application properties. This is to have the Elasticsearch as a vector store integration. This is still from SpringAI, a very handy PDF document reader that we'll use to ingest the manual, which, by the way, the publisher of Runewars just put the manual free online to use. So I thank them for that. This is the dependency for OpenAI, which will pull both the embedding model and chat model. And this is the POM, basically. Now, to the properties. The properties are very important because since we are going to use the auto-configure, this means that this is everything we need to set up. So this is the OpenAI API key, which I have in my environment, so I'm not going to set it up. This is to enable the chat client, otherwise it won't reply to you. And now, since I'm using a local instance of Elasticsearch, I will just configure this, and everything is, of course, in plain view because it's it's a local instance for a demo. But I mean, otherwise, don't do this. Use an environment variable, please. This is the password. The username is elastic, and just for the don't do this. Okay. So these are for Elasticsearch connection, while these are the vector store properties. Initialize schema means that we are going to tell the SpringAI to create an index for us in Elasticsearch. And we are also going to use a new database so that, so let me set an index name as December 11th. Now it's 10:03, so that I'm not cheating with a pre-made index. I might have to if the connection is bad. And yeah, so as I was saying, if you need to use another vector store or another model, all you have to do is just change the dependency here. So this might be, I don't know, whether it's Quadrant or Cassandra or anything. And then you go to the SpringAI documentation and check which properties you need to set, and that's it. The application will stay basically the same. Same for the chat model, embedding model. You go to here and you switch to, I don't know, Llama or anything you want. The one thing that you need to do if you use any other AI model that is not OpenAI is, for the vector store, you will need to set the vector dimension, which is this property here. Because I'm using OpenAI and it's the SpringAI default. But yeah, if you need any other, you need to set the correct vector dimension. Everything is set up, so let's go to the actual application. Standard Spring Boot main, not going to change anything. This is just a simple controller. If you're familiar with Spring, this is nothing novel. So we're just setting up a REST controller which exposes two endpoints, one that we'll use to ingest our PDF manual, and another one which is just for querying. I'll show you the manual. Where it is. Here it is. We'll get it directly from here. It's the same as the one I have here, but mine is in Italian. Yeah, the reg controller will call a reg service, which is what we're going to write now. So this reg service will need the vector store and the chat client. And again, here I'm explicitly declaring it as an Elasticsearch vector store because I want to go into the code later to show you. But I mean, if you can use this one, which is the generic vector store, and just use this. I just need to be Elasticsearch so that I can show you things later. And again, chat client, this is generic. You can use whatever. Let's start with ingesting. As I said, we are going to use a page PDF document reader, which is for Spring, from SpringAI. We are going to use a new one, and we are passing it the path of the PDF manual. We'll read it, and it will output a list of documents, which are the SpringAI documents, of course, and this will be data. If we go and see what's inside a document, this will contain the text, content, some metadata, which in case of PDFs, it's like the page number or some information regarding images. And this will be empty for now, but later it will hold the vector representation of the document as an array of floats. So all right, and this one, the nice thing about the page PDF document reader, it can take both like a local file or a file from the internet. It's the same, just this. Now, we have to take our list of documents and send it to the vector database, but first we do want to tokenize it, meaning we have to split the documents into chunks so that they are more easily manageable by the similarity search. So if page from the manual is too long, we split it in 2 or 3 pages. And for this, we are using a token text splitter, which is right here. And we will apply the data. It will return a list of documents, so we're going just to say data. Finally, we take our vector store and we perform a do add of the data. And this is basically it. As you can imagine, all the magic happens here in the do add, which we're going to quickly see. So you notice that I did not set an embedding model because it's actually already in the vector store itself. So what the add operation does is it takes the documents, performs the embedding, so it fills the embedding here field of the document, and then it performs a call to the Elasticsearch client where it sends it the documents. So we're done with the ingest. Now let's handle the query. We are going to perform a similarity search, so calling the vector store and performing a do similarity search. With a search request, the query will be the question, and now we'll set up a couple of parameters. So top K means how many documents we want to return from the database. And this being a manual, a rule can be referred to by several pages, so I'll go with 5. And then another thing we're going to set is the similarity threshold, which basically means how precise it has to be. It goes from 0 to 1. We are going with 0. We want it to be super specific and just finding exactly what we ask for. Similarity search, which of course returns a list of documents again. And this will be the relevant data. We have a list of documents. We have to turn them into a string. And this will be our context. So we take our relevant data, we stream it, we map it to a document, we get the content, and then we can collect it and separate with like a comma. That's me. Perfect. Now, this is the prompt that I already set up, and let's quickly read what we're going to ask the LLM. We're saying, you're assisting with providing the rules of the tabletop game Rune Wars. Use the information from the document section to provide accurate answers to the question in the question section. If unsure, simply state that you don't know. So the documents will be our context, and the question will be the user query. The question. Lastly, now we have the prompt. We can ask the LLM to perform. So it will return an answer. So we call the chat client with telling it that we're about to send it a prompt, sending it the user question, which will be our full prompt. And we'll call it, and we'll get the content. Now, we have our answer, and a nice thing about using the vector store directly is that we can also retrieve the page where the LLM got the information from, so that we can basically double check if the answer that the model told us is correct. So what we'll return is, we'll say answer plus found at page. So the page will be our relevant data, and I could give it a list of the 5 pages, but for simplicity I'll just get the first pages that it got. So the page number will be in the metadata, and the key is whatever the page, is this page number constant from the page PDF document reader, plus of the manual. This is it. This is ready, and now let's run it. The Spring logo is always a reassurance. Okay, I have a collection set up in Postman, which hopefully you'll be able to see pretty well in light mode. Yes. Okay, we're calling the ingesting path. This is the link to the manual. And if we send it, we should see that SpringAI is processing the PDF. This is the text splitter that is splitting some of the longest pages into chunks. And when it's done, it should say that it's done. So now we can use the query endpoint. Oh, this is what I wanted to ask. But first, let's see the question that I liked most from the beginning. So, is there any way a unit can cross a water border? And I remind you of river trolls from ChatGPT, which don't exist in the game at all. Let's see what it says now. Okay, so if you can see that, so units can cross a water blue border during the winter. All water borders are ignored. Additionally, units with a flighting trait or special cards. This is exactly what we want, found at page 18 of the manual. So let's check out page 18. And page 18 talks about, movement restriction. So it explains how you pass over a water border. So let's try something else. Let's try the other question that I asked, which was, where do you put a reward card after obtaining it? The GPT answer was like face up in the middle of the field somewhere, while Reg empowered ChatGPT says after obtaining a reward card, the controlling players and place it face down under the hero card. Perfect. That's what we wanted. Found at page 27 of the manual. Let's go quickly check it. If you go at page 27, we can see the explanation for reward cards. And that's it. Thank you.
Well,
very quick, this QR leads you to a Google form where you can send me feedback. This was my first ever presentation, so thank you so much for being here again, and thank you for your feedback.
yes,
Thank you.
We have
Have a nice day.
And we have still 4 minutes for questions, so if you have any,
Sure, yeah.
please raise your hand and I will give you a mic.
have you ever tried this with the bigger data set, like books of, I don't know, the domain-driven design, plus unit tests, plus Spring manuals, plus Elasticsearch manuals?
I didn't try this with that many manuals, but I did try with larger ones, and it performs similarly. It does extract and pinpoint, and it can also correlate between, because now what I tried was fairly easy, but one thing I did is I tried to give it like a whole game manual and asking if it could find rule discrepancies, and it actually found a couple. I was surprised.
Okay. Do you have rest of the game with you?
No, the board game is this big. It was bigger than my...
Thank you. Very good presentation. It was very interesting. The question is, can you control how the chunking is done for the documents? Because
Sure.
from what I've seen, that was the biggest issue in terms of the efficiency of the retrieval. So maybe is there any kind of a semantic chunking, or is it able to chunk the documents based on some other criteria?
So I'm using like one token splitter, which is the default one from SpringAI, and the default configuration is to split like every 800 words. So very plainly, yes. But I'm not sure. I would have to check the class for you. But I mean, this was just the default one, so I bet they have something else. Yeah.
Okay, and the last question.
Thank you for the presentation, and I get the question if is it that the instruction for the game is smaller than the entire context of the prompt to the OpenAI, that it answers correctly, or does it exceed the context that is possible to input to the model?
So you're saying if it can get information from...
I'm asking if the instruction would be bigger, would it still work correctly?
You say if the prompt, if we make a bigger prompt,
Yes,
like
yes.
To specify even more.
Yes, or can we be more precise doing querying the Elasticsearch?
Absolutely. Yeah. Okay. The similarity search can be configured pretty extensively, but and SpringAI, it's a bit limited because I mean it uses the algorithm, the KNN. So if you want to use to configure the similarity search like in depth, I would use Elasticsearch directly because Spring simplifies things a lot.
Okay, thank you.
Okay, so thank you again, Laura, for your presentation, and we have a 15 minutes break and switching to Java memory model after the break. Thank you.